Hey everyone. Over the past year or so, I've been working on the power system for H2O AI. I've been trying to port driverless AI onto power. It started off a little rough. There was not a lot of the dependencies we need were readily available, and some compiler differences caused a few issues, but we were able to overcome that, and from that we created a package that's very easy to install and easy to run on power. So now it's distributed as an RPM and Debian package as well as Docker images, and it contains everything you need to get up and go. So you don't have to install anything else. You just install these packages, and immediately you're able to run driverless AI on the power system. I've also been working with IBM to facilitate driverless AI on their IBM Cloud Private platform. It is a very simple build right now, but it does run, and we do have it in different locations running on IBM Cloud Private. So that's just another distribution option that we have found. But recently I've been working on TensorFlow specifically. With IBM, we've helped bring their community distribution of TensorFlow to something we can use on their RHEL systems, which seems to be very relevant now. So they brought their building environment down to Ubuntu 14, so it can run on RHEL 6 and 7. And it does still run on Ubuntu, of course. So this is TensorFlow 1.11. It runs on CUDA 9 currently. That's the only supported version because it's the only one that they build the package with. And it does have GPU and CPU support. So with this incorporated into our build, driverless AI does work with TensorFlow on power right out of the box. You don't have to do anything special as long as you have the CUDA and NVIDIA drivers. Of course, it just is able to go. So I'm going to go ahead and do a demo of that for you now. So for this demo, I'm going to be doing text, natural language processing, and we're trying to do the score of different Amazon reviews. This is a Kaggle data set. So I'm going to go ahead and drop everything that's not text, just so I can go ahead and show off the TensorFlow working within driverless AI. So what we do is we go here to expert settings, and we're going to turn on TensorFlow and turn off everything else. Oh, you can't? Oh. Is it still on the presentation, or here? Can we just come up on the PowerPoint. Okay. You see it now? Yes. Okay. So, here we turn on TensorFlow. Go ahead and turn off everything else. You'll see here I've dropped everything except the summary and text of the review. Here, we'll go ahead and start it and show off that GPU usage. Feature engineering on text problems can sometimes be a little slow, so it will shows why it takes a little bit of time to get into it.
What's it doing behind the scenes here? You can give it a score to text, it's creating features.
Yeah, it's generating features from the text. And then it's using TensorFlow to do all of the modeling with it. So here, while it's running in, I think we can also go to the machine. So this is our power machine running on a Power 9 CPU. And it's still going, so we may be able to catch it running. Yeah, running the TensorFlow models on the GPUs. What? Oh, okay. There. Power 9 TensorFlow model is generating. Looks like one of the GPUs is doing a little bit more work than the others. I can go and show off this experiment that I had finished before. So this is what it looks like after it's finished. You can see the model, or the engineered features that's created. You can scroll over it. It's out of mean fold, weight of evidence, and here we have the word embedding feature, which in this particular one didn't do as well as the others, but it's all using the text fields to generate features. So from this, we have support for all of our different algorithms. And future plans is we're working with IBM currently to optimize this further. There's definitely some room to grow on the Power platform. We're not fully utilizing what's available for us. All of the data transfer rates and all that aren't quite as optimal as we'd like. In the light GBM, we are trying to shift to that, but IBM and NVIDIA decided a while ago that they didn't think it was important to support OpenCL, and light GBM is in fact written in OpenCL. So currently it doesn't allow for us to use GPUs on the Power machine. So we have to figure out what we're going to do about that. Light GBM is definitely something that we're very interested in using opposed to XGBoost. But this GPU issue on Power machines is posing a little bit of an issue. But then we're also going to continue supporting, as new algorithms are used for all of our other platforms, we have to also bring them to Power. So we're going to keep making Power as good as we can. Are there any questions? All right, that's all I have.
Thank you, Pat.